Welcome to Science Snippets Fun Facts and Trivia. Today, we bring you: why was Pluto demoted from planet status? The shocking reason explained. Chapter 1: The Rise of Pluto, a once recognized planet. Section 1: The Discovery of Pluto. In the vast expanse of our solar system, beyond the orbit of Neptune, lies a distant and icy world, Pluto. For decades, it was known as the ninth planet, a symbol of the outermost boundary of our cosmic neighborhood. But how did we first discover this tiny world? The story of Pluto's discovery is one of patience, perseverance, and a bit of celestial detective work. Our journey begins in the early 20th century, with an American astronomer named Percival Lowell. Lowell was fascinated by the idea that an unknown planet X might exist beyond Neptune. His calculations suggested that the gravitational pull on Uranus and Neptune could be caused by an unseen planet. Determined to find it, he spent years searching the night sky, meticulously photographing sections of space and analyzing them for any sign of movement. Unfortunately, Lowell passed away in 1916, without ever confirming the existence of Planet X. But his search was not in vain. His efforts inspired the team at the Lowell Observatory in Flagstaff, Arizona, to continue the hunt. In 1929, a young and self-taught astronomer named Clyde Tombaugh was hired for this very purpose. At just 23 years old, Tombaugh had a keen eye for detail and an unrelenting passion for discovery. His task was daunting. He had to examine countless photographic plates of the sky, comparing them for any slight movement that could indicate a new planet. On February 18, 1930, after months of painstaking work, Tombaugh noticed something extraordinary. A small, faint object appeared to shift between two photographic plates taken days apart. This was the moment of discovery. The object was moving against the backdrop of distant stars, meaning it wasn't just another distant star but something much closer, possibly a planet. After additional observations confirmed its orbit, the news was announced to the world. The ninth planet had been found. The next step was naming the newfound world. Suggestions poured in, but it was an 11-year-old girl from England, Venetia Burney, who proposed the name Pluto. She was fascinated by mythology and noted that Pluto, the Roman god of the underworld, was a fitting name for such a dark and distant planet. The name was officially adopted, and Pluto became a beloved part of the solar system. For over 75 years, Pluto held its place as the ninth planet, capturing the imagination of scientists and the public alike. But little did anyone know, Pluto's classification would one day be questioned, leading to one of the most controversial debates in modern astronomy. Section 2: Pluto's initial classification as a planet. With the discovery of Pluto in 1930, excitement filled the astronomical community. A new planet had been found, and for the first time in nearly a century, the solar system had gained an additional member. But what exactly made Pluto a planet in the first place? To answer this, we need to understand how astronomers classified celestial bodies at the time. In the early 20th century, the definition of a planet was not as rigid as it is today. Generally, any large celestial object orbiting the Sun was considered a planet. If it was not a comet or an asteroid, Pluto, despite being significantly smaller than the other planets, had a stable orbit around the Sun, and didn't seem to fit into any other category. With no clear rules in place, Pluto was simply accepted as the ninth planet of the solar system. However, Pluto's classification wasn't without its uncertainties. Early calculations suggested that Pluto was about the same size as Earth. But later observations revealed that it was much smaller, only about 1,500 miles (2,400 kilometers) in diameter. Roughly two-thirds the size of our Moon. Its mass was also incredibly low, only about 0.2% of Earth's. These surprising findings raised some doubts, but there was no immediate reason to question Pluto's planetary status. Adding to its planetary credibility was its unique composition. Unlike the gas giants Jupiter, Saturn, Uranus, and Neptune, Pluto appeared to be a solid, icy world, making it more similar to the terrestrial planets, Mercury, Venus, Earth, and Mars. Yet, unlike the rocky inner planets, Pluto was composed mostly of ice and frozen nitrogen. This unusual mix made Pluto an outlier, but since there were no other known objects like it at the time, it remained a planet by default. The final seal of approval came with its official inclusion in textbooks, museums, and educational materials. Pluto was embraced as the ninth planet, and generations of students grew up memorizing it as the final stop in our solar system. It became a cultural icon, a mysterious and distant world that represented the unknown frontiers of space. For over 75 years, Pluto's place in the solar system seemed secure. However, as technology advanced and astronomers discovered more celestial bodies beyond Neptune, Pluto's uniqueness began to fade. The very definition of a planet would soon come under scrutiny, leading to one of the biggest debates in modern astronomy. Section 3: Pluto in popular culture. Pluto has always been more than just a celestial body. It has been a source of fascination, inspiration, and even affection for generations. From its discovery in 1930 to its controversial reclassification in 2006, Pluto has held a special place not just in astronomy, but also in popular culture. One of the earliest and most famous references to Pluto in mainstream culture came just months after its discovery. In 1930, Disney introduced a new character, Mickey Mouse's loyal dog, Pluto. Although there is no official confirmation that the name was inspired by the newly discovered planet, the timing suggests a strong connection. This animated Pluto became a beloved figure, further cementing the planet's name in the public consciousness. Beyond cartoons, Pluto has been a symbol of mystery and adventure in science fiction. Countless books, TV shows, and movies have featured Pluto as a setting for space exploration, from classic sci-fi novels to modern blockbuster films. Often portrayed as a lonely, frozen world at the edge of the solar system, Pluto has represented the final frontier, an enigmatic destination waiting to be explored. Pluto's influence extended beyond fiction. Over the decades, it became an essential part of education, with children around the world memorizing it as the ninth planet in the solar system. Posters, models, and diagrams in classrooms all included Pluto as the distant yet integral part of our cosmic neighborhood. Many grew up with an emotional attachment to Pluto, viewing it as a small but mighty underdog among the giants of the solar system. This cultural connection is one of the reasons why Pluto's reclassification in 2006 sparked such an emotional response. People felt as if a piece of their childhood had been taken away. Some even saw it as an injustice, leading to campaigns, petitions, and humorous protests to reinstall Pluto as a planet. It wasn't just a scientific decision. It was a moment that highlighted the deep connection between astronomy and the public's imagination. Even today, Pluto continues to be a pop culture icon. NASA's New Horizons mission, which sent back stunning images of Pluto in 2015. Reignited public interest and reaffirmed Pluto's importance in space exploration. Whether planet or dwarf planet, Pluto remains a beloved figure in science, media, and the hearts of people worldwide. Chapter 2: The controversy begins. Doubts about Pluto's status. Section 1: The size problem. For decades, Pluto was accepted as the ninth planet of the solar system. It was a small, icy world at the edge of our cosmic neighborhood. And for many, that was enough to consider it a full-fledged planet. However, as astronomers gathered more data, one major issue became impossible to ignore: Pluto was simply too small. In fact, it was not just the smallest planet in the solar system, but it was even smaller than several moons orbiting other planets, including Earth's own moon. This realization sparked a serious debate. Could something this tiny truly be classified as a planet? When Pluto was first discovered in 1930, scientists initially believed it was as large as Earth. Some even speculated that it could be slightly bigger than Mercury. But as telescopes improved and measurement techniques advanced, Pluto's estimated size kept shrinking. By the late 20th century, astronomers determined that Pluto was only about 2,400 kilometers (1,500 miles) in diameter, roughly two-thirds the size of our moon. This made it the smallest of all the planets, by a significant margin. Size alone wouldn't necessarily disqualify Pluto as a planet, but its low mass added to the problem. Pluto's mass is only about 0.2% that of Earth, meaning it has very little gravitational influence compared to other planets. To put that into perspective, Mercury, the next smallest official planet, has a mass about 20 times greater than Pluto. The difference is enormous. Because of this low mass, Pluto lacks the strong gravitational pull needed to clear its orbit of debris, a key factor that would later play a crucial role in its reclassification. Another issue was Pluto's density. While rocky planets like Earth and Mars have high-density compositions, Pluto is composed mostly of ice and rock. This made it more similar to the icy moons of the outer planets, such as Neptune's Triton, rather than the inner rocky planets like Mercury, Venus, and Mars. This was a crucial realization. Pluto was beginning to look less like a planet, and more like something else entirely. As astronomers analyzed Pluto's characteristics in greater detail, they started to recognize that it was fundamentally different from the rest of the planets. However, despite these growing concerns, Pluto remained classified as a planet, simply because there was no strict definition of what a planet actually was. This would change dramatically in the early 21st century, when scientists discovered other Pluto-like objects in the outer solar system, forcing a re-evaluation of what it truly meant to be a planet. Section 2: Unusual Orbit. As astronomers studied Pluto in greater detail, they discovered another major issue that set it apart from the other planets: its highly unusual orbit. Unlike the nearly circular orbits of the 8 recognized planets, Pluto follows a strange and eccentric path around the Sun, one that defies the typical patterns seen in the solar system. This raised yet another question: was Pluto truly a planet, or was it something else entirely? To understand this issue, we need to compare Pluto's orbit with those of the other planets. In our solar system, planets follow paths that are almost perfect circles, lying within a flat, disk-like plane known as the ecliptic. This is a direct result of how the solar system formed, out of a spinning disk of gas and dust. However, Pluto's orbit is far from circular. Instead, It is highly elliptical, meaning it stretches into a long oval shape. This eccentric orbit causes Pluto's distance from the Sun to vary dramatically over time. At its farthest point, Pluto is about 49 times the distance between the Earth and the Sun, 49 astronomical units. But at its closest approach, it moves within 30 astronomical units, actually, bringing it inside the orbit of Neptune for a period of about 20 years during each revolution. This means that for a brief time, Pluto is technically the 8th planet from the Sun, not the 9th. But that's not all. Pluto's orbit is also tilted at a sharp angle compared to the rest of the planets. While most planets orbit within the same flat plane, Pluto's orbit is inclined at about 17 degrees. This makes it an outlier, following a path unlike any of the other planets. Instead, its orbit more closely resembles those of certain Kuiper belt objects, small bodies that exist beyond Neptune's orbit. This strange orbit was another clue that Pluto was fundamentally different from the 8 major planets. If Pluto had formed in the same way as the other planets, its orbit should have been more stable and aligned with the ecliptic. The fact that it wasn't suggested that Pluto might have had a different origin, perhaps even being a captured object from the Kuiper belt, rather than a true planet formed in the early solar system. As astronomers gathered more data, Pluto's classification as a planet seemed increasingly uncertain. Its small size, low mass, and highly irregular orbit all made it an oddball. However, the biggest challenge to Pluto's planetary status was still to come: the discovery of other celestial bodies in the outer solar system that looked strikingly similar to Pluto. Section 3: The Kuiper Belt Discovery. For decades, Pluto was seen as a lonely outpost at the edge of the solar system, the final, distant world beyond all the other planets. But that perception changed dramatically in the 1990s, when astronomers made a groundbreaking discovery: Pluto was not alone. In fact, it was part of a vast and previously hidden region known as the Kuiper Belt. A discovery that would ultimately challenge Pluto's planetary status like never before. The idea of the Kuiper Belt was first proposed as early as the 1950s by astronomers Kenneth Edgeworth and Gerard Kuiper. They speculated that beyond Neptune, there might be a collection of small, icy bodies left over from the formation of the solar system. However, at the time, there was no direct evidence to support this theory, and Pluto remained the only known object in that distant region. That all changed in 1992, when astronomers David Jewitt and Jane Liu discovered a small, icy object beyond Neptune, now known as 15,760 Albion. It was the first confirmation that Pluto was not alone. There were other celestial bodies orbiting in the same distant region of space. Over the following years, hundreds of similar objects were found, and the region became officially known as the Kuiper Belt. The Kuiper Belt is a vast zone filled with icy remnants from the early solar system, stretching from about 30 to 55 astronomical units from the Sun. It contains thousands, perhaps even millions, of objects, some of which are similar in size and composition to Pluto. Among these discoveries was Eris, found in 2005. Eris was particularly significant because it was nearly the same size as Pluto, and some measurements suggested it was even slightly larger. If Pluto was a planet, then what about Eris? Should it be classified as the 10th planet? Or did this mean Pluto was not a planet after all? This dilemma forced astronomers to confront an uncomfortable truth: Pluto was not as unique as previously thought. It was just one of many large Kuiper Belt objects. and its planetary status was beginning to look more like a historical accident than a scientific necessity. With each new discovery, the question of what truly defined a planet became more urgent. As the number of known Kuiper Belt objects grew, astronomers faced a choice: either classify dozens of these distant icy bodies as planets, or rethink Pluto's status altogether. This debate would come to a head in 2006, when the International Astronomical Union (IAU) made a historic decision that would forever change our understanding of the solar system. Chapter 3: The IAU's Decision: Defining a Planet. Section 1: The 2006 IAU Meeting. By the early 2000s, Pluto's status as a planet was facing serious challenges. The discovery of the Kuiper Belt and other Pluto-like objects forced astronomers to reconsider what it really meant to be a planet. The growing debate reached a turning point in 2006, when the International Astronomical Union (IAU) convened in Prague for a historic meeting, one that would redefine the solar system as we knew it. The IAU, an organization responsible for naming and classifying celestial bodies, had a difficult task ahead. Up until this point, there had been no formal definition of a planet. For centuries, astronomers simply classified planets based on historical tradition. If an object orbited the sun and wasn't a star or a moon, it was generally considered a planet. This vague definition worked well enough when there were only a handful of known planets. But with the discovery of Eris and other Kuiper Belt objects, it became clear that a more precise definition was needed. The key question was this: should Pluto remain a planet, and if so, should newly discovered objects like Eris also be classified as planets? Some astronomers argued that Pluto's historical status should be preserved, while others believed that science should be based on consistent criteria, not tradition. If Pluto remained a planet, the solar system could soon have dozens of planets, as more Kuiper Belt objects were found. On the other hand, if Pluto was reclassified, it would mean overturning decades of public understanding and education. After intense debate, the IAU proposed an official definition of a planet. For the first time in history, according to their new criteria, a celestial body must meet 3 conditions to be considered a planet. 1. It must orbit the Sun. 2. It must be massive enough for its own gravity to pull it into a nearly round shape. 3. It must have cleared its orbit of other debris. Pluto met the first 2 criteria. It orbits the Sun and is round due to its own gravity. However, it failed the 3rd condition. Pluto shares its orbit with many other Kuiper Belt objects, and does not have the gravitational dominance to clear its surroundings. Because of this, Pluto was reclassified as a dwarf planet, rather than a full-fledged planet. On August 24, 2006, the decision was made official. Pluto was no longer the 9th planet of the solar system. The vote was highly controversial, with only a small fraction of IAU members present for the final decision. Many astronomers and the general public were outraged, feeling that Pluto had been unfairly demoted. Some scientists even refused to accept the new classification, arguing that the definition of a planet was flawed. This moment marked a turning point in astronomy. For the first time, the number of planets in the solar system had been reduced, not expanded. Pluto's reclassification was not just a scientific decision. It was an emotional one, sparking protests, petitions, and ongoing debates that continue to this day. Section 2: The 3 criteria for planets. When the International Astronomical Union IAU made its historic decision in 2006. It wasn't just about Pluto. It was about defining, for the first time, what it truly means to be a planet. Until then, there had been no official criteria for classifying planets, which led to inconsistencies in how celestial bodies were categorized. To bring clarity, the IAU introduced 3 specific conditions that an object must meet in order to be considered a planet. Let's break them down one by one. 1. A planet must orbit the Sun. This first rule seems simple, but it immediately excludes moons and other objects that orbit planets. For example, Jupiter's largest moon, Ganymede, is even bigger than Mercury. But because it orbits Jupiter rather than the Sun, it is not classified as a planet. This criterion ensures that planets are primary celestial bodies within the solar system, rather than secondary objects orbiting larger planets. 2. A planet must have enough mass to be nearly round in shape. Gravity plays a crucial role in shaping celestial bodies. If an object is massive enough, its gravity will pull it into a roughly spherical shape. This is why planets and large moons appear round, while smaller asteroids and comets often have irregular, jagged shapes. Pluto meets this requirement, as do many other large objects in the solar system, including some moons and dwarf planets. 3. A planet must have cleared its orbit of other debris. This is the most controversial and defining rule. It means that a planet must be gravitationally dominant in its orbit, sweeping away smaller objects, and preventing other celestial bodies from occupying its path. The 8 recognized planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, have all cleared their orbits, either by pulling smaller objects into themselves or by ejecting them into space over billions of years. Pluto, however, does not meet this criterion. It orbits within the Kuiper Belt, a region filled with countless other icy bodies. Instead of dominating its orbit, Pluto is just one of many objects sharing the same space. This is what ultimately disqualified Pluto as a planet under the new definition. The third criterion remains the most debated aspect of the IAU's decision. Some astronomers argue that it is an arbitrary distinction, pointing out that even Earth and Jupiter share their orbits with asteroids and other objects. Others believe that without this rule, the number of planets in the solar system would become unmanageable, as many Kuiper Belt objects, and even large asteroids would have to be classified as planets. While the IAU's definition is now widely used, it hasn't ended the controversy. Some scientists continue to push for an updated classification system, and public support for Pluto's planetary status remains strong. However, under the current criteria, Pluto remains a dwarf planet, one of many fascinating objects in the outer reaches of our solar system. Section 3: Why Pluto didn't make the cut. In 2006, the International Astronomical Union, IAU, redefined what it means to be a planet, and under the new criteria, Pluto was reclassified as a dwarf planet. But why exactly did Pluto fail to make the cut? Let's break it down step by step. As we discussed earlier, the IAU established 3 rules that a celestial body must meet to be classified as a planet. It must orbit the Sun. It must have enough mass to be nearly round in shape. It must have cleared its orbit of other debris. Pluto easily meets the first 2 conditions. It orbits the Sun, just like the 8 recognized planets. It also has enough mass for its own gravity to pull it into a nearly spherical shape, meaning it is not an irregular asteroid or comet. However, Pluto fails the third criterion. it has not cleared its orbit of other objects. This is where Pluto's location in the solar system becomes important. Pluto resides in the Kuiper Belt, a vast region of icy bodies beyond Neptune. Unlike the major planets, which have strong gravitational forces that dominate their surroundings, Pluto's gravity is too weak to clear its orbit of other celestial bodies. Instead, it shares its space with thousands of other Kuiper Belt objects KBOs, some of which are nearly the same size as Pluto itself. A key comparison is Neptune. Although Neptune also shares its orbit with objects known as Trojan asteroids, it is massive enough to maintain gravitational control over them. Pluto, on the other hand, lacks the gravitational influence to either eject neighboring bodies from its path or pull them into itself. Instead, it simply coexists with many other icy bodies. Another major issue is Pluto's relationship with its largest moon, Charon. Unlike the moons of other planets, which clearly orbit their parent planet, Pluto and Charon are so close in size that they actually orbit a common center of gravity, known as a barycenter, that lies outside Pluto itself. This makes the Pluto-Charon system more like a binary system than a typical planet-moon relationship. If Pluto were truly a planet, some argued, wouldn't that make Charon a planet as well? The discovery of Eris in 2005 further complicated things. Eris is another large object in the Kuiper Belt, and initial measurements suggested it might be even larger than Pluto. If Pluto was a planet, Eris should be one too. But what about the dozens of other similar-sized objects being discovered in the outer solar system? If Pluto remained a planet, astronomers would either have to accept many more planets, or establish a stricter definition to keep the list manageable. Ultimately, the IAU chose the latter approach, leading to Pluto's reclassification. Although the decision was based on scientific reasoning, it sparked intense controversy, both among scientists and the general public. Pluto had been considered a planet for 76 years, and many people felt an emotional attachment to its status. But despite its change in classification, Pluto remains one of the most intriguing and scientifically valuable objects in our solar system. So, did Pluto deserve to be demoted? Or should the definition of a planet be reconsidered? That debate continues to this day. And as new discoveries are made in the outer solar system, the discussion is far from over. Chapter 4: The Backlash, Scientists and Public Reaction. Section 1: Scientists who disagreed. When the International Astronomical Union (IAU) voted to reclassify Pluto as a dwarf planet in 2006, the decision was meant to bring clarity to planetary definitions. However, instead of settling the debate, it ignited one of the most controversial discussions in modern astronomy. Many scientists strongly disagreed with Pluto's demotion, arguing that the new definition was flawed and too restrictive. One of the most vocal opponents was Dr. Alan Stern, the principal investigator of NASA's New Horizons mission, which sent a spacecraft to study Pluto up close. Stern has consistently argued that the IAU's third criterion, requiring a planet to clear its orbit, is unrealistic and inconsistently applied. He pointed out that even Earth has asteroids and other debris in its orbit, yet no one questions its planetary status. According to Stern, if the same standard were applied to other planets, none of them would fully qualify as planets. Stern and other scientists have also criticized the way the decision was made. The IAU vote took place at the 26th General Assembly in Prague, but only a small fraction of the world's astronomers were present. Fewer than 5% of IAU members actually voted, Many planetary scientists, including those who specialize in studying Pluto, were not involved in the decision at all. Some argue that such a major reclassification should have been based on broader scientific consensus, rather than a limited vote. Another well-known astronomer, Dr. Philip Metzger, has challenged the IAU's reasoning. From a historical perspective, he argues that the concept of clearing an orbit has never been a defining feature of a planet in centuries of scientific literature. Instead, he believes the focus should be on an object's intrinsic properties, such as whether it is large enough for gravity to shape it into a sphere. By this definition, Pluto would still be a planet. Some scientists have even proposed alternative classifications. Rather than reducing the number of planets, they suggest expanding it. One proposal is to redefine planets based on their geological characteristics, meaning any round object that orbits a star would count as a planet. Under this system, Pluto, and many other celestial bodies, would regain their planetary status. The backlash against Pluto's reclassification has also extended beyond the scientific community. Many educators, students, and the general public were emotionally attached to Pluto's status as the ninth planet. Some felt that the IAU's decision was unfairly dismissing Pluto's legacy. This public reaction played a key role in keeping the debate alive, ensuring that Pluto remains one of the most talked about celestial bodies in modern astronomy. Despite the controversy, the IAU's definition remains the official standard. However, as planetary science advances and new discoveries are made, the debate over Pluto's status may not be over just yet. Could the definition of a planet change again in the future? Many scientists think it's possible. Section 2: The public's emotional response. When Pluto was reclassified as a dwarf planet in 2006, it wasn't just a change in scientific terminology, it felt like a personal loss for millions of people. For 76 years, Pluto had been recognized as the ninth planet of the solar system. It was part of school textbooks, museum exhibits, and educational songs that helped children memorize the planets. Then, almost overnight, Pluto was demoted. To many, this decision felt arbitrary, even unfair, and the emotional backlash was immediate. Across the world, students, teachers, and astronomy enthusiasts voiced their frustration. Some educators refused to remove Pluto from planetary models, arguing that scientific definitions should not erase historical and cultural significance. In the United States, lawmakers in New Mexico and Illinois, states connected to Pluto's discovery, went as far as passing symbolic resolutions, declaring Pluto a planet within their borders. Online petitions surged, gathering thousands of signatures from people demanding that Pluto be reinstated. The emotional response wasn't just about scientific classification. It was about identity and attachment. Pluto had always been the underdog of the solar system. Unlike the massive gas giants or rocky inner planets, Pluto was small, distant, and unique. It didn't fit the mold of the other planets, but that only made people love it more. The idea that a committee of astronomers could erase Pluto's planetary status felt like a betrayal to those who had grown up with it as part of their understanding of the universe. Popular culture played a huge role in fueling this attachment. Pluto had been featured in countless books, movies, and TV shows. Disney's Pluto the Dog, introduced in 1930, the same year Pluto was discovered, became a beloved character, further cementing the name in public consciousness. Science fiction stories often portrayed Pluto as a mysterious, icy world at the edge of the solar system. a symbol of the unexplored frontier. Even musicians joined the debate, with artists writing songs about Pluto's exile from the Planet Club. The controversy also sparked humor and satire. Memes flooded the internet, joking that Pluto had been unfairly fired or bullied by the larger planets. Some imagined Pluto as a sad, rejected world drifting alone in space. Even in serious scientific discussions, Pluto's status became a recurring joke, with astronomers frequently asked when they would give Pluto back to the public. But beyond the humor, Pluto's reclassification highlighted a deeper issue: the intersection between science and public perception. Scientific definitions evolve based on new discoveries, but people form emotional connections to ideas, especially when they've been taught since childhood. The Pluto controversy showed that astronomy isn't just about data and classifications. It's also about how people relate to the universe. Despite its official status as a dwarf planet, Pluto remains a planet in the hearts of many. The debate over its classification continues, proving that sometimes science and sentiment don't always align. Whether Pluto is officially a planet or not, its legacy as one of the most beloved celestial objects in the solar system is undeniable. Section 3: Campaigns to reinstate Pluto. Pluto's reclassification in 2006 didn't just spark emotional reactions. It inspired organized efforts to reinstate it as a planet. Scientists, educators, and the general public launched campaigns, petitions, and even political resolutions, all demanding that Pluto's planetary status be restored. The debate has persisted for nearly 2 decades, proving that Pluto's place in the solar system is far from a settled issue. One of the most vocal figures leading the charge is Dr. Alan Stern, the principal investigator of NASA's New Horizons mission. Stern has been a relentless critic of the International Astronomical Union's IAU decision, arguing that their definition of a planet is fundamentally flawed. His main issue lies with the third criterion, that a planet must clear its orbit. Stern points out that Earth, Jupiter, and even Neptune share their orbits with asteroids, yet they are still classified as planets. He argues that planetary classification should be based on an object's intrinsic properties, like being massive enough to form a sphere due to its own gravity, rather than external factors like orbital dominance. Stern's arguments have gained significant support from other planetary scientists. In 2017, a team of NASA researchers proposed a new planetary definition that would include Pluto. Their definition was based on geological activity, rather than orbital characteristics. Under this system, any celestial body that is large enough to be rounded by gravity would qualify as a planet, meaning Pluto and over 100 other objects in the solar system would be reinstated as planets. This proposal reignited discussions within the scientific community, but the IAU has yet to formally reconsider its 2006 decision. Public campaigns to restore Pluto's planetary status have been just as passionate. Numerous online petitions have gathered hundreds of thousands of signatures, urging astronomers to reconsider Pluto's classification. In classrooms, many teachers continue to refer to Pluto as the 9th planet, defying official textbooks. Some museums have even resisted updating their exhibits, keeping Pluto listed as a planet in their solar system models. Political figures have also entered the debate. In the United States, New Mexico and Illinois, states connected to Pluto's discovery, passed symbolic resolutions declaring that Pluto is still a planet. While these resolutions hold no scientific authority, they highlight the deep emotional connection people have to Pluto's status. Even pop culture has played a role in the fight to reinstate Pluto. Countless memes, t-shirts, bumper stickers, and even protest signs have embraced slogans like "Save Pluto" and "Make Pluto a planet again." The controversy has also been referenced in TV shows, movies, and even music. The widespread public backlash demonstrates how Pluto's status isn't just about science, it's about identity, nostalgia, and the way we perceive our place in the universe. Despite all the protests, petitions, and alternative definitions, the IAU has stood by its decision, and Pluto remains classified as a dwarf planet. However, with ongoing discoveries about Pluto's complexity, including its active geology, atmosphere, and potential subsurface ocean, some scientists believe the debate isn't over yet. As planetary science continues to evolve, the possibility of Pluto's reinstatement remains an open question. Chapter 5: What Pluto Really Is. A Dwarf Planet's Characteristics. Section 1: What is a dwarf planet? After Pluto's reclassification in 2006, it was placed into a new category of celestial bodies, dwarf planets. But what exactly is a dwarf planet, and how does it differ from a regular planet? To understand this, we need to look at the criteria set by the International Astronomical Union, IAU, when they redefined planetary classifications. A dwarf planet must meet 3 key conditions. 1. It must orbit the Sun. 2. It must have enough mass for its gravity to shape it into a nearly round form. 3. It must not have cleared its orbit of other debris. At first glance, this definition might seem similar to that of a planet. However, the third condition is the crucial difference. Planets like Earth, Jupiter, and Neptune have strong gravitational fields that dominate their orbits, either pulling in smaller objects or pushing them away. In contrast, dwarf planets share their orbits with other celestial bodies, meaning they lack the gravitational dominance required to clear their path. Pluto fits perfectly into this category. While it orbits the Sun and is spherical, it resides in the Kuiper Belt, a region filled with thousands of other icy bodies. Pluto lacks the gravitational force to remove these neighboring objects from its orbit, which is why it was reclassified as a dwarf planet. Pluto isn't alone in this category. Other officially recognized dwarf planets include Eris, Haumea, Makemake, and Ceres. Each of these bodies has unique characteristics, but they all share the common trait of not clearing their orbits. Interestingly, the classification of dwarf planets is still evolving. Scientists believe that there may be hundreds, or even thousands, of dwarf planets in the Kuiper Belt and beyond. As telescopes improve, we continue to discover new celestial bodies that might fit this category. Despite its new classification, Pluto remains one of the most scientifically intriguing objects in the solar system. It has a complex atmosphere, possible subsurface oceans, and evidence of geological activity, all features typically associated with planets. This has led some scientists to argue that the definition of a planet should be reconsidered once again. So, is Pluto truly a lesser planet, or is the definition of a planet too narrow? That debate continues, but one thing is certain: dwarf planets, including Pluto, are essential to understanding our solar system's history and formation. Section 2: Pluto compared to other dwarf planets. When Pluto was reclassified as a dwarf planet, it was no longer considered unique. Instead, it became part of a new category, alongside other similar celestial bodies. But how does Pluto compare to its fellow dwarf planets? And what makes it stand out? Currently, the International Astronomical Union (IAU) officially recognizes 5 dwarf planets: Pluto, Eris, Haumea, Makemake, and Ceres. Each of them meets the criteria for a dwarf planet, but they differ in size, location, and composition. Let's start with Eris, the dwarf planet that played a key role in Pluto's reclassification. Discovered in 2005, Eris is located in the scattered disk region beyond the Kuiper belt, even farther from the Sun than Pluto. It was initially thought to be larger than Pluto, which fueled the debate over planetary classification. However, later measurements showed that Eris is slightly smaller in diameter, but 25% more massive than Pluto. Its dense, icy composition and highly elliptical orbit make it one of the most extreme objects in the solar system. Then we have Haumea, a fast-spinning, football-shaped dwarf planet discovered in 2004. Unlike Pluto and Eris, which are nearly spherical, Haumea's rapid rotation, completing one full spin every 4 hours, has stretched it into an elongated shape. It also has a unique ring system, making it one of the few known celestial bodies outside Saturn, Uranus, Neptune, and Jupiter to have rings. Makemake, discovered in 2005, is another Kuiper belt object. Similar in size to Haumea, it has a bright, reflective surface covered in frozen methane, giving it a reddish appearance. However, unlike Pluto, it has no known atmosphere, making it one of the coldest and most barren dwarf planets. Finally, there's Ceres, the only dwarf planet located in the asteroid belt. Between Mars and Jupiter, Ceres is much smaller than Pluto. But what makes it fascinating is that it may have subsurface water, raising the possibility of past or even present microbial life. Unlike Pluto, which has a complex nitrogen-rich atmosphere, Ceres is more like a giant, icy asteroid. So where does Pluto stand among these dwarf planets? Despite its new classification, Pluto remains the largest and most geologically active of them all. Unlike Eris, which is covered in a frozen methane layer, Pluto has mountains, glaciers, and even possible cryovolcanoes. Unlike Haumea and Makemake, Pluto has a thin but dynamic atmosphere. And compared to Ceres, Pluto's location in the distant Kuiper belt exposes it to an entirely different set of environmental conditions. Even among the dwarf planets, Pluto is unique. Its complex surface features, atmospheric activity, and potential underground ocean make it one of the most scientifically valuable objects in the solar system. Some argue that this complexity sets Pluto apart from the other dwarf planets, reinforcing the idea that it still deserves to be classified as a full-fledged planet. Section 3: Pluto's unique features. Even though Pluto is classified as a dwarf planet, it stands out in many ways. Unlike other dwarf planets, Pluto has a complex atmosphere, active geology, and even potential subsurface oceans. These unique features make Pluto one of the most intriguing objects in our solar system. One of Pluto's most famous features is its heart-shaped region, officially named Tombaugh Regio after Pluto's discoverer, Clyde Tombaugh. This vast, bright area is composed mainly of nitrogen ice, and is divided into 2 distinct lobes. The left lobe, known as Sputnik Planitia, is a massive glacier that constantly reshapes itself due to convective ice flows, a process more commonly seen on planets like Earth. This active surface suggests that Pluto is not a dead, frozen world, but a dynamic and evolving one. Another striking characteristic of Pluto is its thin but layered atmosphere. Unlike most dwarf planets, Pluto has a complex atmosphere primarily composed of nitrogen, methane, and carbon monoxide. During its closest approach to the Sun, Pluto's surface ice sublimates, creating a temporary atmosphere. As Pluto moves further from the Sun in its elliptical orbit, this atmosphere freezes back onto the surface, a process unlike anything observed on any other known dwarf planet. Perhaps the most surprising discovery was the possibility of a subsurface ocean beneath Pluto's icy crust. Data from NASA's New Horizons mission suggests that Pluto's interior may still hold liquid water, kept from freezing by internal heat and pressure. If true, this raises exciting questions about the potential for life on Pluto, as subsurface oceans are considered prime locations for microbial life. In our solar system, Pluto's moons also make it unique. The largest, Charon, is so big relative to Pluto that the two actually orbit a common center of mass outside of Pluto itself, making them a binary system. No other planet or dwarf planet in the solar system has this kind of relationship with its moon. Pluto also has 4 smaller moons: Styx, Nix, Kerberos, and Hydra, each with unusual, chaotic orbits that add to Pluto's distinctiveness. While Pluto shares some characteristics with other dwarf planets, no other object in its category has such a diverse and active environment. These features continue to challenge our understanding of planetary science, leading some astronomers to question whether Pluto really belongs in the same category as the others. Whether classified as a planet or a dwarf planet, Pluto remains one of the most fascinating worlds in our solar system, one that still holds many mysteries waiting to be uncovered. Chapter 6: Could Pluto be a planet again? Section 1: New Research and Discoveries. Even after its reclassification as a dwarf planet, Pluto continues to surprise scientists. Thanks to advances in space exploration and telescopic technology, we now know that Pluto is far more complex than previously thought. In recent years, new research and discoveries have reshaped our understanding of this distant world, raising fresh questions about its geology, atmosphere, and even its potential to support life. One of the most groundbreaking missions was NASA's New Horizons, which made a historic flyby of Pluto in July 2015. Before this mission, Pluto was little more than a blurry dot in telescope images. But New Horizons changed everything, revealing a stunningly detailed world with towering mountains of water ice, vast nitrogen glaciers, and even possible cryovolcanoes, volcanoes that erupt with liquid ice instead of lava. These discoveries challenge the idea that small, icy bodies, like Pluto, are geologically inactive. Perhaps the most unexpected finding was evidence of a possible subsurface ocean beneath Pluto's thick crust. Data from New Horizons suggests that Pluto's icy shell might be insulating an underground layer of liquid water, kept warm by internal heat. If confirmed, this would make Pluto one of several worlds in the solar system, alongside Europa, Enceladus, and Titan, that could harbor potential conditions for life. Pluto's atmosphere has also been a focus of recent research. Unlike most dwarf planets, Pluto has a thin but dynamic atmosphere, composed primarily of nitrogen, methane, and carbon monoxide. Scientists have discovered that Pluto's atmosphere expands and contracts as it moves through its elliptical orbit. Some models even suggest that, during parts of its orbit, Pluto's atmosphere may freeze entirely and collapse onto the surface, only to reappear when Pluto moves closer to the Sun. Another major discovery concerns Pluto's interaction with the solar wind. Unlike planets with strong magnetic fields, Pluto lacks significant protection from charged particles streaming from the Sun. However, New Horizons detected an unusual plasma tail, showing that Pluto's atmosphere is slowly being stripped away into space. This process is similar to what happens to Mars, offering new insights into how planetary atmospheres evolve over time. Despite being billions of kilometers away, Pluto remains a hot topic in planetary science. Researchers continue to study data from New Horizons, and future missions are already being proposed. Some scientists have even suggested sending an orbiter or lander to Pluto, which could provide definitive answers about its mysterious interior and atmosphere. Each new discovery challenges our previous assumptions, proving that Pluto is not just an icy rock at the edge of the solar system. It's a dynamic world still full of secrets waiting to be uncovered. Section 2: Scientists pushing for change. Even years after Pluto's reclassification, the debate over its planetary status is far from over. Many scientists continue to challenge the International Astronomical Union's (IAU) definition of a planet, arguing that Pluto and many other celestial bodies should be reinstated. These researchers are not just driven by nostalgia. They believe that the current classification system is flawed and outdated, failing to reflect what we now know about planetary science. One of the most vocal critics is Dr. Alan Stern, the principal investigator of NASA's New Horizons mission. Stern has consistently argued that the IAU's definition is too restrictive and inconsistent. He points out that even planets like Earth and Jupiter haven't technically cleared their orbits, since they share space with asteroids and other objects. According to Stern, planetary classification should be based on an object's intrinsic characteristics, such as being massive enough to form a sphere due to gravity. In 2017, Stern and a team of planetary scientists proposed a new definition of a planet, one based on geophysical properties rather than orbital behavior. Under this definition, any celestial body that is large enough to become spherical under its own gravity would qualify as a planet, regardless of whether it has cleared its orbit. This would not only restore Pluto's status, but also dramatically increase the number of planets in the solar system, potentially including over 100 objects such as Ceres, Eris, and even some of the larger moons. Other astronomers support modifying the definition as well. Dr. Philip Metzger, a planetary physicist, has argued that the IAU's definition is not based on historical scientific literature. He notes that for over 200 years, planetary classification was focused on an object's geological complexity, not its ability to clear its orbit. Metzger's research suggests that Pluto, with its atmosphere, active geology, and possible subsurface ocean, fits the criteria of a planet better than many of the recognized 8 planets. Despite this ongoing push for change, the IAU has not revised its definition since 2006. However, with each new discovery about Pluto's dynamic nature, pressure continues to mount for a reconsideration. Future missions, such as potential Pluto orbiters or landers, could provide even more evidence to support the idea that Pluto is far more than just a dwarf planet. For now, Pluto remains classified as a dwarf planet, but the debate surrounding its status proves one thing: scientific definitions are not set in stone. As our understanding of the universe evolves, so too may the way we define what it means to be a planet. Section 3: What would it take for Pluto to return? The debate over Pluto's planetary status has been ongoing for nearly 2 decades. But what would it actually take for Pluto to be reinstated as a planet? Would it require a new scientific breakthrough, a change in classification rules, or simply a shift in public and academic opinion. One of the most straightforward ways Pluto could regain its status is if the International Astronomical Union (IAU) revises its definition of a planet. The current criteria, established in 2006, require a planet to clear its orbit, a rule that disqualified Pluto. Many scientists argue that this requirement is too restrictive and inconsistently applied. If the IAU were to adopt a geophysical definition, focusing on whether an object is large enough to form a sphere under its own gravity, Pluto would immediately qualify as a planet again, along with over 100 other celestial bodies in the solar system. Another way Pluto's status could change is through new discoveries about its structure and behavior. The more we learn about Pluto, the more it challenges traditional ideas of what a planet should be. Evidence suggests Pluto has a dynamic atmosphere, active geology, and possibly even a subsurface ocean, characteristics that are typically associated with planets, rather than small, inactive celestial bodies. If future missions confirm that Pluto has conditions suitable for sustaining some form of life, the push to reconsider its classification could gain even more momentum. Public and scientific pressure could also play a role. While the IAU made the decision to reclassify Pluto, not all planetary scientists agree with it. If enough researchers continue to challenge the definition and push for change, the IAU might be forced to reconsider. Similarly, if public demand remains strong, educational institutions and media could continue treating Pluto as a planet, keeping the debate alive. Finally, there's the possibility that Pluto's status will change, simply because scientific definitions evolve over time. History has shown that astronomy is not static. Our understanding of the universe is constantly improving, and classifications change as a result. Just as Pluto was once considered a planet, and then reclassified, future discoveries may reshape how we categorize celestial bodies altogether. For now, Pluto remains a dwarf planet, but as new research emerges and scientific perspectives shift, the question remains open: will Pluto ever reclaim its place as the ninth planet? Only time will tell. Chapter 7: The Legacy of Pluto, More Than Just a Classification. Section 1: Pluto's Influence on Space Exploration. Pluto may be small and distant, but its impact on space exploration has been anything but minor. From its discovery in 1930 to the groundbreaking New Horizons mission, Pluto has played a significant role in advancing our understanding of the solar system. Its influence extends beyond just planetary classification. It has shaped how we explore the outer reaches of space, and inspired future missions to even more distant worlds. One of Pluto's biggest contributions to space exploration is the New Horizons mission. Launched by NASA in 2006, this spacecraft was the first to visit Pluto, revolutionizing our knowledge of this icy world. Before New Horizons, Pluto was little more than a blurry speck in telescope images. But in July 2015, the spacecraft completed its historic flyby, capturing high-resolution images and detailed data that transformed our understanding of Pluto's surface, atmosphere, and geology. New Horizons revealed Pluto as a dynamic world, with nitrogen glaciers, towering ice mountains, and even signs of possible cryovolcanism. These discoveries challenged the old assumption that small, distant celestial bodies are geologically dead. The mission proved that even at the edge of the solar system, planetary activity continues. This finding has since influenced how scientists study other icy worlds, such as Europa and Enceladus. which may also harbor subsurface oceans. Beyond Pluto itself, the success of New Horizons demonstrated that missions to the outer solar system are not only possible but also incredibly valuable. It paved the way for discussions about future Kuiper Belt exploration, as Pluto is just one of many objects in this distant region. Since its Pluto flyby, New Horizons has continued traveling through the Kuiper Belt, studying other mysterious celestial bodies like Arrokoth, a primitive object that provides clues about the early solar system. Pluto's influence isn't just scientific, it has also played a major role in public interest in space exploration. The excitement surrounding New Horizons sparked global curiosity, reminding people of the thrill of discovery. The mission proved that even decades after its discovery, Pluto still had the power to captivate the world. As technology advances, new missions to Pluto and beyond are being proposed. Some scientists have suggested sending an orbiter, or even a lander to study Pluto in greater detail. If approved, such a mission could answer lingering questions about Pluto's interior, atmosphere, and potential for underground oceans. Pluto's exploration has already reshaped our understanding of the outer solar system, and its story is far from over. Whether as a planet or a dwarf planet, Pluto continues to inspire new missions and scientific breakthroughs, proving that even the smallest worlds can have a big impact on space exploration. Section 2: The Future of Pluto Research. Pluto's reclassification may have changed its official status, but it hasn't diminished scientific interest in this distant world. In fact, Pluto is now viewed as one of the most intriguing objects in the solar system, and researchers are eager to uncover more of its secrets. With advancing technology and growing interest in Kuiper Belt exploration, the future of Pluto research looks promising. One of the biggest goals for future missions is to return to Pluto, not just for a flyby, but for a long-term study. The New Horizons mission in 2015 provided incredible insights, but it only observed Pluto for a few hours as it sped past. Scientists now want to send an orbiter, a spacecraft that could spend months or even years studying Pluto up close. An orbiter could map its surface in detail, monitor atmospheric changes over time, and even search for signs of a subsurface ocean, one of Pluto's most exciting possibilities. Some researchers are even considering a lander or rover for Pluto, though this would be far more challenging. Pluto's extreme cold as low as -240 degrees Celsius and thin atmosphere make landing a spacecraft difficult, and any rover would need specialized technology to survive such harsh conditions. However, if successful, a Pluto lander could analyze its icy surface, detect underground chemical activity, and confirm whether an ocean lies beneath its crust. Another major area of future research involves studying Pluto's moons, especially Charon. Pluto and Charon form a binary system, unlike anything else in the solar system. Future missions could determine how this unique relationship affects Pluto's geology and atmosphere. Additionally, Pluto's smaller moons, Styx, Nix, Kerberos, and Hydra, could provide clues about how Kuiper Belt objects form and evolve. Beyond Pluto itself, scientists are also interested in other dwarf planets and Kuiper Belt objects. Pluto is just one of many large icy bodies in this distant region, and comparing it with other objects, like Eris, Haumea, and Makemake could help us understand how these worlds formed. Some missions are already being proposed to explore the Kuiper Belt further, using next-generation telescopes and spacecraft, with NASA and other space agencies planning new deep space missions. It's only a matter of time before Pluto is visited again. The more we learn, the more we realize that Pluto is not just a distant frozen rock. It's a dynamic and scientifically rich world. Whether through orbiters, landers, or future telescopes, Pluto will continue to be a key focus in our exploration of the outer solar system. Section 3: Why Pluto Still Matters. Pluto may no longer be classified as a planet, but that doesn't mean it has lost its significance. In fact, Pluto remains one of the most fascinating and scientifically valuable objects in the solar system. From its complex geology to its role in redefining what it means to be a planet, Pluto's impact on space exploration and astronomy is undeniable. One of the main reasons Pluto still matters is its scientific uniqueness. Unlike many other celestial bodies in the Kuiper Belt, Pluto has a dynamic atmosphere, possible subsurface ocean, and active geology. These characteristics make it far more than just a frozen rock. At the edge of the solar system, the discovery of ice mountains, nitrogen glaciers, and possible cryovolcanoes challenges our understanding of how small, icy worlds evolve. Pluto also plays a key role in studying the Kuiper Belt, a vast region beyond Neptune filled with icy objects left over from the early solar system. By understanding Pluto, scientists gain insight into the formation of planetary systems and the conditions that existed billions of years ago. This knowledge extends beyond our solar system, helping astronomers study exoplanets and distant star systems. Beyond science, Pluto's cultural and historical significance keeps it in the public eye. Generations grew up learning that Pluto was the ninth planet, and its reclassification sparked one of the biggest public debates in modern astronomy. Whether people agree with the change or not, Pluto remains a symbol of our evolving understanding of the universe. The excitement surrounding Pluto's exploration, especially with the New Horizons mission, has also inspired a new generation of scientists and space enthusiasts. The mission's success proved that even distant, small worlds are worth exploring, and that space exploration still holds surprises. Finally, Pluto continues to challenge the way we define planets. Some astronomers argue that the current classification system is too limited, and as research continues, future discoveries may lead to another redefinition. Whether or not Pluto is ever reinstated as a planet, it has played a crucial role in shaping scientific discussions and will continue to do so. Pluto may be small, but its importance is massive. Whether classified as a planet or a dwarf planet, it remains a key to unlocking the mysteries of the solar system. And as new missions explore the outer reaches of space, Pluto's story is far from over. If you found this video helpful or interesting, please give it a thumbs up and subscribe to the channel.